Hello, everyone. I hope you all are doing great. Let's see. We're going to look today about symmetry. So today we will talk about symmetry so we can describe reflection that takes in the figure itself. You know you have it when we need symmetric figures or when we define symmetric figures. What is symmetry? I believe you all have seen it and know it, but to describe, I'm not sure. So what is symmetry? Two or more parts of figure could be identical when reflect or slide or rotate. So if you see this one, the A, if you have a line goes through in the middle of A, and if you flip, it's gonna go fit exactly over here. That is called symmetry. In here also same thing, if you flip, this is the line, if you flip this, and it's gonna be exactly fit this half onto the bottom half. All right. In here, if you look at it, look at the first figure. Is it symmetric? Yes. This has a line goes through it. And if you flip this, it's going to fit right exactly on top of it. So it has one line that goes through and make it symmetry. How about in here, this line? Yes, it is. If you look at 3D, if you just have it in the space, it is not. So look at it. If you flip this one, like we are talking about in the space, some people look this as a 3D, but don't do that. Just look at in the space, and if you have it, if you flip this, it's not gonna fit because this one is more lengthier than this line. So when you flip it, it's not gonna fit. It's gonna fit over here. How about in here? If it's a plane, it is not. Same thing over here, it is not. Same thing over here, it is not. But when you view it, sometimes it looks 3D. If it looks 3D, you can be able to do it. How about in here? In real life, you can see these kind of leaves. Of course, I mean, when you flip it, it's gonna go on top of every leaf. This leaf gonna go on top of this one gonna go on top of this, that one gonna go on top of this. Also, this is just flipping it. When you rotate it, like from this leaf, if you rotate over here, this leaf gonna come over here. In the center, we are rotating it. And then this leaf gonna be here, this leaf gonna be here. So this also can rotate and show the symmetry. Here are 4 pictures or 4 figures. Look at it. This is equilateral triangle. So how many line of symmetry? You can have 1. If you flip it, it's gonna go, it's gonna be symmetric, and another one in here, it's symmetric, and the third one over here, it's symmetric. In this figure, there are many symmetric. 1, 2, 3, 4, 5, 6. So it's going to be 6. You know why? Because it goes through 1 over here, 2 over here, the third one over here. Also in between those petals. Those are also symmetry. Same thing over here. 1, 2, 3, 4, 5. So it should be 5 symmetry. See how I figure out the pattern? This is 1, 5 line of symmetry, 2, 3, and 4, and this one is 5. All right. So in here, how many corners? 1, 2, 3, 4, 5, 6, 7, 8. It has to be equal. Each side has to be equal. So then I can say this is octagon. 1, 2, 3, 4, 5, 4, 8. So it should be 8. Just count it. 1, 2, 3, 4, 5, 6, 7, 8. Because we counted already this one already. 1, 2, 3, 4, 5, 6, 7, 8. So in octagon, if all the sides are equal, then it will be 8 line of symmetry. So basically we looked at it, these are line of symmetry and all reflection of symmetry you can call. This is what we like, what is line of symmetry or reflection symmetry is. 2 or more parts identical when it's reflect. Our face, most of the time, it's reflection symmetry, because half of the face, I mean, like if you flip it, if you take a picture of it, you cut right in the middle, and if you flip it, it's gonna go on top of the other one. Equilateral triangle, if you cut it, you can have 3 line of symmetry. In here, we just can have 2, I mean, 1, because we have only, as a face, you can have only over here. But if it's equilateral triangle, you can have 3 of them. If any figure has each side are equal, then you count the vertex. And most likely, most of the time, that many symmetric line you can draw. In a butterfly, you just have 1 line, like the same thing as our face. Rotational symmetry. If a figure still look the same after some rotation, then it's called rotational symmetry. You look at this, this is rotational. It goes all the way here. When it's come, it's upside down. If you rotate in the middle, it's basically 180-degree rotation. So that's also you can call order 2 symmetry. There's no order 1. That's mean it's 160 degrees, it's going to be the same thing. Order 2, it's 180 degree. How we figure that out? You take 360 and see how many times before you rotate, how many times it becomes symmetry, and then you can call that many time order. In here, it's 1, 2, full rotation. So if you have 2 ordered symmetry, you take that 2 and divide 360 by that number, order 2, which is 2, which is 180. So each time 180 degrees, it's going to be symmetry. In here, order 3 symmetry. This also is the same thing. If you see 3 petals and with an equal angle distance, then this is called order 3. So how many degrees rotation we have to make it to symmetry? We're just going to take this 3 and divide 360. So it's going to be 120 degrees. Each 120 degrees, it's going to be fit exactly on top of the other one. Order 4, you do the same thing. It's going to be 90 degrees because 360 divided by 4, it's 90. Here's an example of a rotational symmetry. If you look at it, it can rotate, and if it's stopped in this much, I mean, like if this seat, it's going to rotate over here. And then if you look at it, you're not going to see any different unless there's a color difference. If it's all the seats over here are same color, then you're not going to see different. So this is an example of rotational symmetry. Point symmetry. Every part has matching parts in a figure, then it's called point symmetry. Also 180-degree rotation. also point symmetry. So if you rotate this one, this way 180 degrees, this one gonna fit exactly in here. If you look at it, these are the exact same points, these are exact same point, these are exact same point. Anywhere you do it, it's going to be exact same point. So it's 180 degrees. So let's see if we have, we're just going to look into a few things and see if we can draw some symmetric and see how do we do it. So let's say x-axis symmetry, we just click it, x-axis always horizontal, left to right it goes, and which color you want to take. I mean, I'm just going to draw. I want to draw with green. Let's say butterfly. I'm just going to draw. I'm not a big artist, but I will try my best. See how does it work? And if you want to choose a color, and if you put a circle over here, it's going to be on the other side. And if I want to fill violet over here, all right. I'm bad with colors, so anyway. You know. So you take this part and then you flip it. Not take it and put on top of it, just flip it. It will fit exactly on top of it. You can do y-axis now. If you want to do something over here, another butterfly, I will do another butterfly over here and see what happens. Oops. And fill the color. I will send you those links. If you want to play around, just play around it. I mean, all the slides, so you can look into it. So this is how you do it in x-axis, I mean y-axis, this one. You can do x is equal to y, which is diagonal. If you want to delete these things, you can delete. And I will do diagonal. X is equal to y, and y is equal to negative x, and then you can start to draw. So how many, I mean, like, you know, for example, clear, 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 clear. So now just say you draw a star. How do we do it? I'm just going to try my best. And then I tried my best, but it's not equilateral. But if you have a center point over here, center point over here, I'm just going to make it as a circle. If you rotate it, if it's equilateral, all the triangle, I mean, those two triangles has the same exact size or congruent sides. If this vertex or point comes here, this one gonna go over here, this one gonna go over here, this one gonna go over here, and so on. So it's a rotational symmetry too. Also, you can draw a line. If you draw y is equal to x, I mean, it should be going through this one if it's equilateral, then you can see that's also a symmetry. X-axis and the y-axis. If you move this up, if you move this, it's going to be symmetric, okay? So you can play around with that. I will send you the video, I mean like its slides. And let's see if we can do a few questions and see we are getting those things. How many lines of symmetry does this shape has? If you look at it, I would say you can draw one over here, two over here, three over here, and then in between, this is the fourth one, fifth one, and the sixth one. So it should be 6. Let's see. Yeah, it is 6. So I count 1, 2, 3, 4, 5, 6. 6 of them over here. I just counted because all the sides are equal. So that's how I found it. Let's see if we use the technique over here and see what happened. In here, those sides are not equal. So I can say only over here in the middle. If we cannot go over here or over here or over here. So I can say 1. Let's say, yep. And how many over here? M. You know, you can cut half over here. You cannot cut over here. So it should be 1. How about in here? Those sides are not equal, like, you know, all those sides. So we can conclude with the vertex. So I would say if you cut it, if you flip it, it's not going to fit. How about in here? If we cut it and if you flip it, yes. So I can say it's 1. How many lines of symmetry on this shape has? It's pretty much look the same each side. So I'm going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to be 6. See, easy way to find it. All right. How about in here? We don't know. This is a different shape. Only thing we can cut this way. And how about in this way? So I can say 2. Yeah. This one, I will let you do it, pause it and do it, and let me know. Count those, because this one looks like a square, so it has 4 corners or 4 vertex, so I would say 4. Pretty simple, huh? So let's see. So I'm going to show you one more thing, and then we will call for the day. Just stop sharing. And I want to share with this. Okay. So what is this shape? This is called parallelogram because these two sides are parallel, these two sides are parallel. But does it have any symmetry? let's say if we cut this way, how many of you think it has a symmetry in this line? A lot of people think it might have it, but the reason is it is not. If you fold it, this one gonna go over here. So it's basically gonna look like this. See, it didn't fit in the same exact corner, so therefore, this is not the line, okay? How about in here? Same thing, this corner going to be here. So that's going to look over here like this. So that is not symmetry, that line also. In here, if you cut it, it's not gonna fit in the same way. It's the area, if you cut in the middle, the area might be the same, but it's not gonna fit exactly the same. You can flip this and then you put on the top of it, yes, but if you fold it, this one gonna end up over here. It's further than there. This one gonna end up over here. All right, not that way. Same thing this way too. All right, maybe this also not gonna work. You know the reason? If you fold it, this one end up over here. And this one going to be here. That is how it's going to look. All right. So parallelogram doesn't have any symmetry. Just to make you, sometimes they will trick you with this question. All right. And if it's other than that, if we have like all the angles are same, then it has a rectangle. It's going to be a rectangle that has it. The thing is to find the lines or the vertex, you have to find out all the sides are equal and the interior angles are equal. Then you can determine on those vertex. So just an example. If you have a rectangle, then it could happen. There will be some vertex, line of symmetry. One is this. If you flip it, it's going to be, the other one is here. Why it's not 4? We cannot count the vertex. Rectangle has opposite sides are equal, not all the sides. But if it's square, then it will work to count the vertex. If it's square, if you cut it, this one gonna go over here. Same thing over here if you cut it, and there's another one. So you can count 1, 2, 3, 4. So 4 lines of symmetry. All right. That is square. I think I put that as a little slide, okay? And you can find anything. If it's octagon, it's equal. The interior angles, all the interior angles are equal to each other and the sides. And then you count how many in octagon? 8 corners. So it's going to be 8 symmetrical lines, all right? So if you have any questions on that, please feel free to email me or text me. I will put the phone number over here, 401-408-3392. You can text me and make an appointment to come to the office hours. Whoever come to office hours, they are doing great. All right. So I hope you all gonna come and get the help and then pass the class. Also, I just want to mention that there are some focus area, and in the focus area there are content assessment. You have to do it, I think, Already 2 of them are red for most of the people, so please look into it and let me know if I can help you on that. And pretty soon we will have a unit assessment, and then if you do it, you will be, I mean, if you get a good grade, you will be all set for the quarter. So be ready and try to finish up all the focus areas and checkpoint that we already have it. Thank you. You have a wonderful day.